JVM is a complex mix of various elements, from class loader to heap memory and stack memory. There is a lot under the hood. Now, trying to explain all these things in just one video, it's kinda impossible. They are like puzzle pieces, each with its own story. So for now, we are zooming in on stack memory. It's like a special area inside the JVM. So the agenda of this video is to understand the difference between call stack and stack memory and how they work seamlessly together inside the JVM. Get ready for an animated journey where we break down the internal functionality in a simple and engaging way. Let's keep it simple and learn together. Stay tuned. The Java stack memory is a key player in the execution of Java programs. It is where the local variables, object references, and method invocations are stored and managed in flow manner. It is also unique for each thread. It means if our application contains multiple threads, we also have multiple stack memories inside the JVM. Now let's try to dig down it a bit more to understand it more clearly. In order to pinpoint each memory location in program's memory, we assign each byte of memory an address. The address goes from 0 all the way to the largest possible address depending on the machine. By convention, we express these addresses in base 16 numbers. For instance, the smallest possible address is 0x tetra 0 tetra 0, and the largest possible address could be 0x tetra f tetra f, where the 0x means base 16. The stack segment is near the top of memory with high address. Each time a function is called, the machine allocates some stack memory for it. When a new local variable is declared, more stack memory is allocated for that function to store the variable. Such allocations make the stack grow downwards. After the function returns, the stack memory of this function is deallocated, which means all local variables become invalid. The allocation and deallocation of stack memory is automatically done. Now, apart from stack memory, there is one more thing known as call stack. Don't confuse it with stack memory. It's a different thing. A call stack is a data structure that keeps track of function calls in a program. It follows the same first in last out operation, meaning that the most recently called function needs to end first before executing the rest of the program. Unlike the stack memory, it is only one for the entire program. It's not thread based. Whenever a function is called in Java, a new frame is created and pushed onto the call stack. Now let's try to understand it with the stack memory using some cool animations. So consider this is a Java program with a simple main method, two integers and a string. Now what will happen inside the JVM? First of all, a main method is called into the call stack. When it is inserted into the call stack, it starts creating the local variables inside the stack. If you check the value of C in stack memory, it's like weird memory address. This is because stack can't store non-primitive values. It holds the address of these values and the actual value resides inside the heap memory. If you want to understand this concept in detail, I have attached the link in the description. Check that out. Now let's say we have one more method in the Java program that contains value x. Now inside the call stack, a new member is pushed and also a newcomer in stack as well. Now once the value x is returned, these both newcomers will be popped from both of the stacks. This is how stack push and pop methods and values and make free memory for newcomers. If stack gets full of entries, then we have to confront stack overflow error. So always avoid making unnecessary variables and always make variables in the required scope. I have bunch of interview questions regarding this topic coming your way in YouTube Shorts. So for that, subscribe to the channel and stay tuned. Keep learning. I will see you in the next video.